example 2, we're going to take the three major properties of logarithms and use them to practice expanding logarithms. Okay, so if you read the directions, these are the directions you're going to see for expanding logarithms. Okay, so it says write each expression as a sum and or difference of logarithms. Okay, express powers as factors. Okay, so again, the directions might be a little confusing, but the key here is you are given one logarithm. Okay, if you scan the exam, each one of these guys is one logarithm. Okay, there are no equal signs. Okay, these are not equations. We're not solving for x. Okay, so when it says sum and or difference of logarithms, okay, that's kind of hinting that we have to expand. We're taking this one logarithm and it's going to be like you're turning it into the logarithm of something plus another logarithm minus another logarithm. You're writing it as a sum and or a difference of multiple logarithms. Okay, this part in the directions where it says express powers as factors, that I'll explain what that means when we get to an example where that applies. Okay, all right, let's take a look at the first one in example A here, part A. We have log base 3 of x over 9. Okay, so we have to expand this guy. Okay, it's going to turn into multiple base 3 logarithms. Okay, we have the logarithm of a fraction. So if you go back to page 1 and look at your properties, remember if you're expanding, okay, let's go back. Let me erase this. Okay, if we look at our properties, okay, if we are expanding, oops, this, let me fix that. If you're expanding, you're applying the properties in this direction. You're taking one logarithm and turning it into multiple logarithms. Okay, same thing with this property. Okay, so you're taking one logarithm, turning it into multiple logarithms. Okay, this is the property we need for part A. We have the logarithm of a fraction, so we know that division turns into subtraction. Okay, so this is going to be log base 3 of the top minus log base 3 of the bottom. Okay, so that's what that turns into. You've taken one logarithm and you've expanded it into two logarithms of the same base. Okay, so that's as far as you can break it up. Okay, the only other thing you can do here, and it's kind of optional, there's nothing we can do with log base 3 of x. However, I'm going to come out to the side and talk about log base 3 of 9. Okay, remember, this is going to equal a number. Okay, if you do the arrow thing, this is saying 3 to what power gives you 9. Okay, so that's 2. 3 times 3 is 9. Okay, so log base 3 of 9 equals 2. So if you wanted to, and again, it's not a requirement, you could go one step further and say minus log base 3 of 9 is 2. Okay, so either this or this you can use as your final answer. Either one is acceptable. Okay, all right, in part B, okay, we're looking at the natural log of x times e to the x. Okay, so again, we're trying to expand here. We have one logarithm that we're going to turn into multiple logarithms. Okay, again, you have to ask yourself here, when you're doing these types of problems, you're trying to align it with the three major properties of logarithms. You have to ask yourself, do I have the logarithm of something times something? Do I have the logarithm of something divided by something? Or do I have the logarithm of something to a power? Okay, well, when you look at this, okay, this is the logarithm of something times something. Okay, so what we're doing inside the parentheses, we are multiplying the quantities x and e to the x. Okay, so if we're expanding it, we're going to have to use property 1. Okay, so let me erase this. Okay, we're concentrating on this property right now. Okay, the logarithm of something times something, multiplication turns into addition. Okay, so this is going to be, when we expand this, they're all going to be natural logarithms. Okay, so this is going to be the natural log of the first thing, which is x, plus the natural log of the second thing. Okay, so that's how that expands. That one natural log has now turned into two natural logs that we're adding together. Okay, can you go any further? Definitely. Okay, you can do something with this. Okay, you can't do anything with natural log of x. Okay, but we have learned that if natural log and e are side by side, okay, they will cancel out, and so the x will come down. Okay, so this is your final answer. Okay, I'll go ahead and box that for you. Okay, all right, moving on. Okay, let's take a look at part C. Okay, parts A and B were kind of straightforward and simple. Now we're starting to get into more complicated things. Okay, part C, we have log base 5 of the cubed root of x squared plus 1 over x squared minus 1. Okay, so there's a lot going on here. This is one logarithm. We're trying to expand it into multiple base 5 logarithms. Okay, overall, what is going on here? Is this the logarithm of something times something? Is it the logarithm of something divided by something? Or is it the logarithm of something to a power? Okay, yes, there's a ton going on, but overall, it is the logarithm of a fraction. Okay, so we're going to have to use property number 2 here. Okay, so it's, to start this off, okay, it's the logarithm of a fraction. So division will turn into subtraction. Okay, so this is going to be log base 5 of the top minus log base 5 of the bottom. Okay, now keep in mind the numerator was all kept intact by the cubed root. The bottom here, okay, has more than one term. We need to keep those two terms together. So we're going to have to put them in parentheses. You would be taking the logarithm of that entire quantity. Okay, all right, so it's broken up into the log base 5 of the top minus log base 5 of the quantity in the bottom. Okay, all right, now anytime you have a cubed root in this case, or a square root, or a fourth root, or a fifth root, you're gonna have to kind of eliminate the roots. Okay, so watch this. In the next step, this is going to be log base 5 of, we've talked about this in a prior section. If you have a cubed root, it is the same thing as raising that quantity to the 1/3 power. Okay, so since we're taking the cubed root of x squared plus 1, it's the same thing as taking x squared plus 1 and raising it to the 1/3 power. Okay, so just stick with me. Right now, I converted from the radical form, the root, to a power. Okay, and then there's nothing I can do over here. Okay, so remember the directions where I told you I was going to talk about this whole express powers as factors business? Okay, what that means, okay, is if you have a situation like you do here on the left where you have a logarithm of something to a power, your last step is going to be to bring that power down. Okay, so since we have the logarithm of something to a power, that power can come down in front. So we're going to end up with 1/3 times log base 5 of the quantity x squared plus 1, and parentheses are necessary there, minus log base 5 of the quantity x squared minus 1. Parentheses are required there. Okay, this is the final answer. Okay, this is what it looks like if you expanded this logarithm. Okay, when you're expanding, the last step is going to be bringing any powers down like we did with the 1/3. Okay, something I really want to mention here, this is mega important. Okay, you see a couple of things here. Okay, you see log base 5 of x squared plus 1. And on the right, you see log base 5 of x squared minus 1. You might be very, very tempted to distribute here. Okay, you might say, oh, this is log base 5 of x squared plus log base 5 of 1. Or over here, you might be tempted to say, this is log base 5 of x squared minus log base 5 of 1. This is a no-no, okay? You cannot distribute through logarithms, okay? You absolutely cannot distribute through logarithms, okay? I am putting a big time no. Well, that doesn't really look like I'm scratching it out. Let's do this, okay? This is a no-no. No. I'm putting a big no here. As tempting as it might be, it's not allowed. Okay, so I'm putting right here, no. You cannot distribute logarithms. It's an absolute no. Okay, that's why what I have in the box is the final answer, and we don't go further by distributing because you can't. The only three things that are allowed with logarithms are the three things right here. Okay, I'll even put right here, well, that does not look like you cannot distribute logarithms. Okay, and I'll even write an example up here just to remind you on the front page here. If you have log base 5 of x squared plus 1, that does not equal log base 5 of x squared plus log base 5 of 1. Okay, it is a no-no, like a major no-no. You cannot distribute logarithms. Okay, I don't know how to make this very visible. You cannot do it. Okay, don't even try ever. Okay, all right, we have one more to do here. Okay, I will put that in the next video.